So my name is Praveen Gupta. I work for MITRE. This this talk is around private RAN sharing. This is kind of a deep dive on Professor Hanning's keynote, where he was talking about access being decentralized, with the core being shared, and the core network being part of the MNOs. I couldn't agree more. I think most of the operators are already offloading a lot of their access to Wi-Fi. And in fact, 70% of what the operator traffic today is actually offloaded to Wi-Fi. And most of the traffic, as you go into the offices and homes, is carried through Wi-Fi. So there's already a lot that operators have done in terms of coming out of the access business. And I think they can do more in that direction. Enterprise NextG needs are going to be to connect to a 5G network as you are in the campus, and preferably connect. Also have a private 5G network as you are in the campus, and also connected to one of the two MNOs, typically 2 or 3 MNOs. And as you move out of the campus, you stay connected on the enterprise side as one of the MNO slices. And then as you move to another campus location, you then go back and connect to MNO inside the campus, as well as on the private network inside the campus. So that's the kind of a template most of the enterprise is going to adopt for 5G deployments, and kind of enable services on top of that. But here is the problem. The G node B based RAN sharing is not really scalable. So, for example, if you look at San Francisco as a city, that it would be covered typically by about 15 to 20 macros. Now, typical city of San Francisco size would typically have about 800 to 900 enterprises, maybe more, who are interested in 5G, and you can't really have all those 800 enterprises connect to the core network of the MNOs. So you can't really scale using RAN based G node B based RAN sharing. So what's the solution? 3GPP has already started opening the RAN interfaces more and more. G node B in 5G is already disaggregated into in RRU and DU and CU. Won't go much into this. It's well published and well known architecture, but basically this separation creates a Midhaul, which is basically an interface which is 3GPP defined, that separates creates a DU, which is an interface between the DU and a CU. IAB is another technology that has been standardized starting from release 16. And that is a technology which combines an MT and a DU together to create a relay. And this relay can be effectively used to densify the macro network of the operator. So hierarchical cell structure can be created as you use F1 and IAB interfaces. Without IAB densification, the 5G network, 5G macro would have to serve all the customers inside and outside the building, which is not really feasible. So IAB and F1 based small cells can be connected to the macro to create a hierarchical cell structure, and that hierarchical cell structure can be used and deployed at scale for all the cities, and be easily enable densification with good mobility as you go in and out of the building. But the key question is, so now on the technology side, we have solved the problem, but what about the business side of the problem? How does the business side of this problem get solved? Because it's very clear that most of these operators will not have a good ROI to deploy their own network and fund it for all the buildings. So what is the business? How to solve this on a business side? I think the solution is heterogeneous ownership, much like what Professor Hanning was saying, which kind of democratizes the access and opens access for all these individual owners to deploy and then connect to these MNOs and share the RAN with the MNO. I think F1 and IAB can be a good interface to do that and build heterogeneous ownership around it. So what's new in this research? I mean, if you look at how RAN sharing is proposed in different forums today, especially on the on-go alliance architecture, they are actually looking at shared EPC and then connected to the individual EPC beyond the shared EPC and kind of combine and create a common EPC with all the privately owned G-Node Bs. And whereas what MITRE is proposing is to do it at the DU level and then connect to the different MNOs using the F1 and IAB interfaces. So I think one of the key problems to solve as we go try to democratize access is how to solve it for the spectrum piece. If you compare it with Wi-Fi, like Wi-Fi is being easy to deploy mainly because it comes with a license, it comes with a spectrum built into it. And unfortunately for 5G, the first thing you have to figure out to deploy 5G is to get the license for the spectrum, and that's not an easy task to do for most enterprises. Though CBRS is available, but it still costs money to license a CBRS spectrum. It's not free, so it's not a good comparison to compare Wi-Fi and 5G from a cost perspective, and that's a big barrier to adoption. One of the ideas that I think we can explore is which kind of also solves the public safety problem. One of the key findings from the 9/11 attack was that lives could have been saved if there was connectivity available inside those World Trade Towers. So it's actually a priority for public safety to provide access inside the building, which is kind of a federal priority today or public safety priority today. So one of the ideas could be that the public safety FirstNet spectrum becomes licensable by these enterprise owners to deploy inside the building, as long as they do provide connectivity to the public safety on a priority basis for free, and then use it for their own private purposes or connecting to MNOs for the rest of the traffic. Other options could be that MNOs, when they are not deploying their own spectrum or their own network inside the campuses, they start licensing using some kind of an open license model to their campuses and lower the cost of entry for 5G networks. Similarly, one needs to solve the spectrum issue for DoD and most of the federal 5G deployments going forward. So in terms of the spectrum and RRU sharing, what we propose is to have the RAN slicing being created at the RRU level, which would be supporting the different networks as part of different RAN slices, and is deployed inside the enterprise at scale, and then be connected via a shared DU architecture with the different MNOs and for private networking. So the overall architecture is going to look like this, where the shared RRU is then connected to a kind of a shared DU architecture, which then connects to the respective CUs via Midhauls, one being private and the other two being for different MNOs. These MNO connections can happen through F1 interface over IPsec, tunnel between the proxy and the gateway, or you can also use IAB to connect from MNO to the private RAN. And this can be an effective mechanism to support MNO traffic on a private RAN. So this is how the private RAN sharing is going to look like with MNOs for inside the building architecture, and which does allow an orchestration, RAN orchestration via some kind of a RIC, which is privately owned but is shared in terms of the shared interface to the MNOs. In terms of the private ownership, so I mean this RAN sharing model may not be just limited to sharing the RAN with MNOs. You could also very much use it for private to private partnership. For example, if some of the federal for example, if some of the federal agencies want to develop their own 5G network and want to do RAN sharing, they can enable that. This can be enabled as a private ownership partnership model. This can also be used for development of a network on a tactical side. For example, DoD, if Navy and Marines are coming together for certain deployments and want to share the network, this model can also be extended to support coalition networking between different coalition partners. So the desired goals for collaboration. So MITRE doesn't do most of the research on its own. We do open most of our research for collaboration. So we invite the community to join us in this collaboration, in this research effort, and the desired goals for this project would be to identify the spectrum licensing options that can be used to enable a 5G network on an enterprise. Also create open source open source link analysis tool, which can be used to identify if you have coverage for MNOs without any private RAN sharing type of requirement inside the building, or you do need some kind of a extension of MNO network to bring the network inside. And what we have seen is that because of the devices being battery powered devices, the reverse link is the weakest link. And as you go inside the wall, a lot of MNO signal gets lost. So most MNOs should really create their own link analysis tool, which can then be used by the building owners to see if they will have a problem within their building or not. The third objective is to develop a shared RAN architecture and solution demo, which can be then used as a template for 5G enterprise or NextG enterprise deployment and connection to the MNOs. We do want to engage with the MNOs as well in this partnership and develop a model that would work for MNOs to connect via Midhaul. And last but not the least is to contribute this technology to the standards. So as I was saying, right, I would like to, based on this collaborative research, I would like to create a 4-step template for private network deployment, out of which the first step is to do the licensing, spectrum licensing. The second step is deployment of the 5G network using a private MEC edge platform, and connect that 5G network to the MNOs using a Midhaul secure Midhaul interface, and be able to perform as a 5G network, shared 5G network for enterprise as well as MNO needs. So we invite the industry to collaborate with us, both MNOs as well as academia and vertical industry to fund and collaborate and develop this program to make enterprise 5G ready for easy deployment by the industry and adoption. That is my last slide.
Thank you very much.
Thank you.